Software Engineering Radio Episode 52, DSLs in Ruby. Okay, welcome Obie to this episode of Software Engineering Radio. We're going to talk about agile DSL development in Ruby. So once again, this DSL stuff, but now implemented in a host language.
It keeps coming up, doesn't it?
Yeah.
The DSL topic is definitely hot.
Yeah, definitely. And we've talked about model-driven development and these more static approaches. So looking at the dynamic approaches in Ruby is probably the next important step. So let's get started with maybe talking about what a DSL actually is. We talked about that before, but just trying to formulate it in your words.
Well, the way I tend to introduce DSLs to people that haven't heard about the concept before is to relate it to jargon, which is a concept that most people are familiar with.
Yeah.
And one of the dictionary definitions of jargon is the language, especially the vocabulary peculiar to a particular trade, profession, or group.
Yeah.
And that's a very useful way of introducing the concept of a DSL to an audience or whoever you may be discussing it with, because everyone is familiar with domain-specific language examples in their day-to-day life, even if they're not familiar with them, or they don't recognize them as such.
Yeah.
And a DSL is simply a way of using some programming language technology to capture that jargon or a subset of jargon for a particular task in an executable form.
Yeah. So the executable form is important. So it has to be formal.
There has to be some degree of formality. There has to be some way to execute it. Otherwise, it's just some sort of spec or something, right?
Yeah. So that's also the difference between specs and DSLs.
Correct.
DSLs are executable.
Correct.
So, and do you want to briefly elaborate on the difference between external and internal DSLs and why you probably think internal DSLs are more useful?
Sure. Internal versus external is something that was introduced by Martin Fowler in the relatively recent past, perhaps last year. He wrote an article called Language Workbenches.
Yeah, which we'll put into the show notes.
Yeah, it was about language-oriented design, which has to do in part with DSLs. The external versus internal distinction was one that perhaps had not been made the same way before. I know it had been described in different ways. Internal is a way of describing a domain-specific language which is implemented within the framework of a general-purpose programming language, such as Ruby, for instance. Or I think the grandfather of all these techniques is perhaps Lisp.
Yeah.
Because programming in Lisp pretty much is a continuous exercise of building up narrower and narrower domain-specific languages.
So I guess one of the key capabilities of a language in order to make it useful for implementing internal DSLs is that the syntax is flexible or tweakable or something, and Ruby has a very flexible syntax.
It has a very flexible syntax. Most things in Ruby can be done at least two ways.
Yeah.
For instance, blocks can be defined in a typical multi-line format with do and finishing with end. Or you can use curly braces.
Yeah.
The fact that you can do it both ways actually gives you some flexibility as a language designer, as a domain-specific language designer.
Yeah. So, and some people say that the reason why it was easy in Lisp to design DSLs is because Lisp doesn't have a syntax at all, because you basically write the trees directly.
Yeah, that's exactly it.
So let's look at DSL examples. There is one that I really like. It's about ordering coffee, right?
Yeah, it's ordering coffee. So for our American listeners and wherever the Starbucks is the predominant way to get your caffeine fix, you know that if you walk into a Starbucks and you say venti half calf non-fat no foam no whip latte, they will know exactly what you mean, even though outside of that context it makes absolutely no sense at all. So that was an example I gave in the talk as my lead into a toy example that we could implement as a DSL. Yeah. So another one might be Route 66, swinging easy on the chorus, extra solo at the coda, and bump at the end. And by the way, these are a couple examples that my colleague Neil Ford, who also talks about DSLs, used in his OSCON presentation about DSLs. And I thought they were kind of cool as real life.
Yeah, right. Real life
examples. Yeah.
And they also illustrate that if you don't know the context of the DSL, the program probably doesn't make much sense, because I read these slides and I didn't recognize it. Now, I'm not American, but still I didn't know you're talking about coffee, so maybe, it was hard to recognize it.
Yeah, again, the fact that it's a narrow domain, but the person that would, if this was some sort of software that we need to implement, the person validating it, the person helping to define the spec, the presupposition is that, yes, they would know.
Yeah. So, there is a frequently recurring discussion about what's the difference between a framework and APIs and fluent APIs and a DSL. So how would a traditional API-based implementation of such an API basically to order coffee look like? It's obviously a bit hard to describe APIs and program source code in an audible form only, but we'll try. So.
Well, it's just a couple of lines. So I gave an example of what I described as not a particularly good API-driven approach to this, but it was basically in Ruby code latte.new, and then it takes 3 parameters, so which are 3 constants: venti, half-calf, non-fat. Yeah. That gets you an order object instance. And then from that order, you can invoke prepare. And in this case, in the case of the example in the talk, I passed the false parameter. And the part of the point is that even though this is completely normal code, within the context of my talk, part of the point is you don't know exactly what that false is.
Yeah, because it doesn't say such and such equals false. It's just
correct.
The actual
There's no
parameter.
Keyword parameter.
Right,
it's just it's actually passing a false.
Yeah.
So if we're looking at this as someone who's not familiar with the implementation of this code, we actually have to go and look at the API in order to understand it.
Yep.
So in the API, you would look at, for instance, the definition of the prepare method and see that, it takes 2 parameters, add foam and add whip. And because it's a latte, add foam is true and add whip is false.
Yeah.
Okay. I mean, that's normal code.
Yeah.
That's very typical of what you find all over the place.
Yeah. And actually for you folks, Java programmers, it basically looks the same, because using constants and calling the constructor, it's basically the same thing. So now let's look at how it could also look like if we do it with a language that does have a flexible syntax. You couldn't do that in Java, right?
I don't think you could do this in Java. I mean, you can... Let's go back to that in a second.
Yeah, okay.
So in the DSL-ish example in Ruby, the line would literally read latte, venti, comma, half-calf, comma, non-fat, comma, no foam, comma, no whip.
Yeah.
So it's almost exactly word for word,
right.
The description.
And there's no function call parentheses, and there is no new call, so it doesn't look like, as you said, it doesn't look like a program.
It doesn't necessarily look like a program. You can, because I've included, for instance, underscores, which didn't need to be there, but it just, was the way that came out. Then you can kind of tell that it's sort of vaguely programming-like.
Yeah.
The fact that in the example, for instance, I assigned it to an order variable, things like that. But even to a non-programming person, who was on my team as perhaps a domain expert or a business analyst, if I sat him down next to me, which is one of the principles of agile, is to include people in the process, right?
Yes. Yeah.
And I said, "Does this look right?" He would read it and he would say, "Yeah, that looks right."
Yeah.
Even the person who is completely intimidated by programming in general, which we meet those on the job.
Yeah.
We can bring them in and perhaps with some coaxing, we say, "Can you please look at this?"
Yeah. And this is a really interesting point you make, because I've mentioned that before. I don't think it is very realistic to have the real domain experts actually write the code.
Correct.
But if you do pair programming with a domain expert and you have a notation that doesn't put him off as soon as he sees it, that's a big advantage already.
It's a huge advantage.
Yeah. So you don't have to talk about specs. So how do you go forward if you design a Ruby DSL? Is there like a process or best practice of steps that you'll do?
Yeah, this is from our practice.
Yeah.
So we've done this a couple of times on real projects in ThoughtWorks. Yeah. The advice that I give actually is don't try to do your abstract meta model first.
Yep.
That would be the process of going through analysis up front and trying to create a class model and the object model that you're going to base your DSL on.
Yeah.
So I say don't do that first.
Yeah.
I say together with the domain expert or you're an analyst, capture your DSL concepts in valid Ruby syntax.
Yep.
So if you're a Ruby beginner, you may have a bit of difficulty with this.
Yes, indeed.
And if you're not a particularly good writer, for instance, so if you don't express yourself very well in writing, you may have a little bit of problem with this.
Yeah.
Correct? There's some underlying prerequisites that are necessary to be able to use this technique. However, if you can write a little bit, if you understand the dynamics of language design a little bit, and you know valid Ruby syntax, then you're ready to go.
Yep.
You can basically sit down and have a conversation, a dialogue with the user to, or whoever's driving your domain, and just say, well, what are the requirements that we're going to cover? So, for instance, if we were trying to implement some business rules for our application as a DSL, let's describe some of these business rules, and we may just start by capturing the vocabulary.
Yeah, yeah.
That would be the process of starting to develop an ontology. Basically, what is this jargon? What's the lexicon of this jargon? Yeah. We put those down, and it's very, very easy. As actually I showed, I think in some of the, for instance, with the latte example, it's very, very easy to put down code without worrying about the implementation, and you can even check the Ruby syntax to make sure it's okay.
Yeah.
And you can just iterate over that. So
just like example or even test-driven, right? So you start with the test case first, and then you implement the language, we'll talk about that later, until it works.
Yeah. Sometimes it's more than one expert you want to run it by.
Yeah.
Oftentimes it is an exercise of analysis because you have to find if you're doing it in DSL rather than hard coding things just in a traditional sense, there's got to be some driver for that. So what we found is that it's quite often advantageous to use DSLs in order to capture the business rules, which are mostly common, but they vary.
Yep.
So in the case of the bank that we worked with, we were capturing business rules related to how they compensate their partners.
Yep.
And the thing is that they mostly compensated their partners in very similar ways, but every single partner had a contract which was negotiated independently and had little quirks and little differences that made it unique from the others.
So in this case, you describe the contracts with these rules formally as a DSL and not as just a Word document.
Correct. They had many Excel documents and Word documents, and actually the contract itself, which they were using to do their analysis and basically plug in these business rules, I say with air quotes, because it wasn't truly a rules-based system. It was just a custom PL SQL implementation of a rules-based system. And part of the problem is that the errors can cost a lot of money because you have no good way other than by running the beast and checking the results of seeing, is this correct according to the contract? You don't have, so on the left side you may have your contract, right, in the language, the spec, if you will. On the right side you don't have anything. You have a bunch of PL SQL, which doesn't make any sense to anyone except who wrote it. So in this case, we went through and created a DSL which matched the contract language as closely as we thought we could do it. So now on the left side you have your contract, on the right side you have your DSL script.
And now you have something to relate to.
Correct.
And we'll put probably some of these slides into the show notes so people
absolutely.
can see that.
I think we should.
One thing that is really cool, I'm looking at this moment, that you can actually treat numbers as objects and then write $5 in order to express that it's not just 5, it's actually $5. So this is actually cool. So we'll put more of these in the show notes. So I get the impression that writing DSLs in Ruby is quite a natural way of working with Ruby. In fact, many people say, and I'd agree there, of course, that Ruby on Rails, the raison d'être, the Ruby these days maybe, is actually a DSL for web development, right?
It's a collection of DSLs.
Oh, right, yes.
Around the whole process of developing web apps.
Yeah.
So, yeah, it's important to note that calling Rails itself a big DSL is only true in the most abstract sense.
Yeah,
right?
It addresses several domains like persistence, presentation, and transaction. So it's a collection of DSLs.
The point is that I think it's very important for people to realize that if your DSL is too encompassing, if it spans too many areas, even if it's too big within a certain domain,
yes, it's going to suffer.
It's going to suffer because the language that you use, even within a particular domain, the semantics of that language is very dependent on context.
Yeah. Although the other view would be that it's like a philosophical discussion whether you say there is one big DSL that has several partitions for different aspects of the problem, or whether you say you have several DSLs that you combine together in order to solve a bigger problem. That's like the usual discussion. The point is that the different aspects of a complex systems require different syntax, different meta models, different formalisms.
That's correct, and I would say Rails proves that true.
Yeah.
One of the key differentiators being that it's all Ruby.
Yeah.
So whereas in other systems, in other ways of putting together web app, for instance, even if you had fluent interfaces, there may be a combination of different technologies.
True, yes.
Many, many different flavors of XML, so on and so forth.
It's probably two reasons why this works in Ruby. One is the syntactic sugar, so the flexible syntax, and the other thing is Ruby's meta-programming facilities.
Yep.
So I think we should talk about these now to get a feeling for our listeners how to actually implement the DSL, because writing down stuff is not all. So what are some of the syntactic sugar elements that make DSL development in Ruby easy?
Well, one of the first things is the fact that the parentheses are optional. Very, very important.
Yeah.
Because the fact that I can leave off parentheses when I call a method, it lets the language flow much more naturally. It lets it be less intimidating to a non-programmer, so on and so forth. Yeah. Less line noise. And if you strive for simplicity in your DSL design, then you'll want to leave off any unnecessary parentheses just to let it read closer to natural language, correct?
Yeah.
Another thing, too, that's very important and useful is the fact that in Ruby we use symbols, which are basically intern strings, as names, as identifiers. And symbols are denoted with a colon.
Colon, yeah.
So basically any string that starts with a colon, that's a symbol.
Yeah. And just to add to that, since Ruby is a dynamic language and you don't have compiled or static typing in, for example, in your editor, there is no real difference between writing a keyword, a method call, and a symbol, because it's all kind of the same thing. It's only interpreted at runtime.
Right.
That's why you can mix symbols, method calls, and things kind of without noticing it.
Yeah, as long as it's valid syntax.
Of course, yes.
You know, and you get used to it. There may be some discomfort, I would say, coming over from a Java background, with things being like that. You know, in the way that you described the fact that you mix all these things together in many different ways. Yeah, the syntax is a bit looser. Yeah, but it yields a lot of benefits for DSL. You know, what we were talking about as far as syntax sugar, the blocks. Yeah, for instance.
So what is a block?
Very, very valuable. A block is essentially there's different ways to describe it, but it is a closure. Basically, it's a function.
Anonymous?
It's an anonymous function that you can pass around. You can assign it to a variable. Yeah. And many methods in Ruby, or methods that you define yourself, can take a block. Yeah. In fact, the block can be optional. Yep. Which is useful. Yeah. And then the block lets you delay execution. of
So you
some bit
can
of code.
capture the context, put it somewhere, hand it around, and
Correct.
execute it later.
Yes, absolutely.
So for some of the Java programmers who unfortunately don't have this feature in their language, it's maybe like a command pattern with a lot of syntactic sugar.
Yeah.
That's maybe
Yeah,
the other
that's correct.
explanation.
Because a lot of times you're just going to need that particular command implementation just once.
Yeah.
So you don't want to extract it to somewhere else. You want it in line so that it actually has the context for you to understand it.
Without having to define an anonymous inner class with an execute
that just
method
becomes noise.
Yeah, you can't do this.
Yeah.
So the next thing that I saw in Ruby is like literal hashes and literal arrays, where you again leave away the parents and therefore...
The fact that, literal arrays are present in Java.
Yeah, true.
Literal hashes are not.
Yeah.
And actually this is one of my favorite features of
Absolutely,
Ruby.
yeah.
The fact that you can very, very elegantly, I think, pass around just these literal hash.
Yeah.
Using a notation where you use a little arrow symbol. So it's the, equals greater than.
Yeah.
And it's just so beautiful, for cases where you need to pass things that look like keyword arguments.
Right, exactly, yeah.
So for instance, going back to my, we were discussing the fact that Ruby programming in general tends towards DSL-ish kind of things, right? If I went back to my original coffee example, and I wanted to improve that by making it a little bit more DSL-ish, I may change the method signature of
this false thing, right?
Yeah, the false thing, so that when I call prepare, instead of having just two normal arguments,
like false and true,
right, I would pass a hash.
Yeah.
And the hash would use symbols as keys to say add whip and add foam.
Yeah.
And I would actually say add whip arrow.
True.
Yeah.
Yeah.
So the point is that in that case, the person that came along and had to maintain that code or had to verify that code is correct would actually read it and have the context there, and it would be more expressive.
Yeah.
And that's really the key that we're striving for.
And again, for the static language person, this sounds strange because you lose type safety and you have this hash as a parameter, but in the end in Ruby it doesn't matter. Since everything is dynamic, it doesn't matter whether you pass arguments that are not checked at compile time or in the editor, or whether you pass a hash, because both are not checked, so both are kind of the same level of guarantee statically, which is basically none.
Yeah, if you need to enforce some contract on those parameters, then you do so, and we quite often do.
So you basically check like if there is this in the hash and if it isn't.
In fact, the way that many Rails methods are implemented is that they take varying different types.
Yeah.
For instance, the find method. This is one of the most basic things you can do with Rails, is to use the active record framework to find the record. The find method on active record takes an ID. So basically, if it receives a numeric as the first parameter, it will look up that row by ID.
Yeah.
If it receives the keyword expressed with a symbol first, it will return the first row. You get my point? It can be polymorphic in terms of the parameters. It's very, it's very different than what we're used to in Java and so on.
Yeah.
There's examples that I give, for instance, that so many things in Rails are just very good examples of DSL-ish type code. Very expressive code. I want to emphasize that the key point here is not to create a DSL for the sake of creating a DSL.
Yeah, of course. Yeah.
Right? It's a whole philosophy, it's a whole mentality about how you write your code in expressive fashion.
So the example we just have in front of us is like you can take a class, you can add a keyword like acts as state machine, and then you can define states. And the point is that making a class act as a state machine actually has to change the behavior of the class.
That's
there has
correct.
to be something like trigger, and then something has to move. So we, as a consequence of writing state and then colon stalled, for example, where colon stalled is a symbol, you have to actually modify the class as a consequence, which brings us to meta-programming and self-modification.
Yep.
Right? So let's talk about some of these features then, I guess.
There's a really good quote by James Bach, who is a well-known figure in the Rails community. He works with 37 Signals, has contributed a lot to Rails, including Capistrano, which is our deployment framework. So he said the trick to writing DSLs in Ruby is really knowing what you can and can't do with Ruby's metaprogramming features.
Mm-hmm. Yep.
Yeah, like you were saying, the part of what makes this possible to work in this way and to make it so expressive is the fact that, for instance, in that example, when I say access state machine and then give it its initial state, there's a lot going on under the scenes. It's not subtle at all. There's methods being created. There's state being changed. There's database columns that will be accessed now.
So and this is one of the really cool things that I was really glad to see in Ruby when I took a look at it first. So you have to picture this. You define a class such and such, like for example, class story, subclasses extends goal, and then you can literally write acts as state machine. And this, what looks like just a keyword, is actually a method call that is evaluated upon class definition and then as a consequence changes the class, right?
Yeah, as this class is getting initialized, you can execute methods on it that have been mixed in or that come from a superclass. Yeah. And those methods can contribute to the construction of that class and to its behavior by adding methods and behavior to it.
In the end, it's self-modifying code, right?
Yeah.
Which has been criticized historically at some point sometimes.
Well, but I mean, they're also referred to as higher order functions because they're functions that, create other functions.
Yeah. Okay, so let's look at the set of features that are typically used for building DSLs, metaprogramming features.
There's definitely different ways of creating DSLs, and the particular way that these were identified was, I think, in a blog posting by James Buck. Mm-hmm. So he went through and said, okay, well, there's I see 4 different ways, and I happen to agree with him. So the first one is instantiation. Is simply a DSL that is composed of methods on an object.
Yep.
And Builder is an example of this. Builder by Jim Wyrick, who's a legend in the Ruby community, is a very, very good little API for building XML. Mm-hmm. And the way that works is that you create an XML markup object instance, which is part of the Builder library. Yep. Now you have this reference, and you capture that in a variable, which we normally call XML for obvious reasons. Mm-hmm. Okay, and then this Builder object has a couple of special methods, for instance, like instruct bang. Yeah. The bang denotes that it's a special method. There's something going on there, and that basically generates an instruct tag near the top. But then everything else, it doesn't really have any other methods other than a method missing callback. Method missing, for those not familiar with the concept, is all objects in Ruby end up with a method missing method by default.
Method inherited, right?
Yeah. And what that does is it throws an exception which says, I don't have this method.
So what happens is, in your client code, you call a method that doesn't exist on the class or on the object, and then
on purpose,
and then the callback is invoked, and then you can react.
Yeah. So normally objects definition of method missing is to throw an exception. You override it.
Right.
When you override it, you make it, for instance, in this case with Builder, to say, okay, I'll take whatever method you called and use that as the name of the tag. Yeah. That I want to create.
Yeah, and probably then return the Builder object again, so you can do this recursively or repeatedly.
It also leverages the fact that Ruby blocks, are so powerful, and you can pass your execution context around. Yeah. So the fact that I nest using a block structure, again, further calls to XML creates nested structures in my XML.
And again, to the Java programmer, it looks strange because you call a method that's not there, and the Java compiler would simply say, "Hey, compile time error doesn't work." Yeah. But here, because everything is executed or evaluated at runtime, it's just something you can react to at runtime.
Yeah, it's very, very different than a frame-based language where the methods have to be known. Yeah, Ruby is message-oriented, just like Smalltalk. So even though you define methods on a class, whenever you are invoking a method, you're basically sending a message.
Yeah, I never really got the difference between sending a message and invoking a method. It's philosophical, I guess.
Yeah, probably a topic for another time. But the point is that because it's treated in that way, you can have message handling for unknown messages.
Right.
Which enables this kind of thing.
Yeah.
So class macros is a different way of achieving the same kind of DSL results with expressive code. This is used very, very widely in Rails, for instance.
Yeah. Belongs to, has many.
Yeah, it's what we were talking about a few minutes ago as far as defining methods at the class level, which you then invoke in, for instance, subclasses.
Yeah.
Like you said, access state machine, for instance, is one that you can mix in. And here, for instance, we see an example of a rule set, something I pulled out of one of my existing projects.
Yep.
Belongs to global criteria, belongs to a partner, has many comments. These things get executed as the class is initialized, and it goes through a series of behavior because of that, and it changes the structure of the class.
Yeah. To again picture this, you have a class, it extends from some base class, or it mixes in some kind of mix-in, and then you can call the methods that this superclass has in it, static methods.
Correct.
You can call them, and as part of the definition of the class you're currently working in, this method is executed, and it can do whatever it wants. For example, use things like instance eval or class eval to actually modify the class that's currently created on the fly.
Yes.
This is actually really pretty cool.
Yeah.
And, it's like a meta-object protocol in CLOS and stuff.
Yes, yeah, absolutely. And later on we'll get into even cooler stuff you can do, like, for instance, read part of the class definition from a database. So now you're mixing your data is code and your code is data, and all sorts of fun stuff like that.
Yeah.
Another way of implementing a DSL in Ruby is to use top-level methods. So this is more appropriate to the person that's building some sort of utility. Or
so top-level methods, you mean, are not associated with a class? Or?
Well, there is a main execution context at the beginning of execution of a Ruby program. So if, for instance, you define methods in that context, then they will be available in that top-level context.
Yeah.
The main example of this is Rake.
Yeah.
Rake is the build tool.
Ruby's make.
Yeah, Ruby's make.
Yeah.
And we use it in the same way that you would use Ant in Java. Or
I wonder why people didn't call it Rant.
I've seen some called Rant, actually, that try to be more like Ant.
Okay.
But Jim Wyrick, who I said before, is a legend, is a very talented guy, wrote this thing called Rake, and it's beautiful. And it is an example of a DSL is targeted at the domain of building. So it doesn't. I remember that the first time I heard Rake described as a DSL, it kind of struck me as odd because I'm used to thinking of DSLs as leaning more towards natural language, expressivity. But the point is that someone who is thinking and working in the domain of building software. Yes, it is a natural domain. DSL. Yeah, exactly.
Yeah, that's why I usually distinguish between technical domains and business or functional domains, and make or Rake or building would be a technical domain.
Correct. So in order to use Rake, basically you just include Rake's methods. It basically sets up the context, and then you just suck in your script and load it, and then it gets executed.
Yeah.
And I showed the audience an example of a custom task from one of my projects. It finds a namespace, describes, it gives a description, wipe database, task action, task clear, depends on environment, and then takes a block for what to do.
And the depends on is written as a hash, basically, again. So you write task such and such, and then the arrow, and then another task name.
Correct.
That's really nice. Yeah.
So you see that there's a little bit of a mental mapping going on there, because in fact, I didn't even think about it. But when I read task clean, the clean arrow environment, right, I read as clean depends on environment.
Yeah, of course.
And there is a bit of that mapping that actually you can teach your domain experts and your analysts to understand that little bits of Ruby syntax, for instance, like the arrow to mean as, or
especially if those people don't know Ruby in the first place, so they don't have to replace the meaning they already know for the symbol with something else. Correct. It's just to tell them this means this.
Now, sometimes I say, with Ruby DSLs, is how far down the rabbit hole do you want to go? Because, for instance, Jay Fields, who's a very good friend of mine at ThoughtWorks, and one of the guys that's been pioneering some of this stuff with me, we can, for instance, replace that arrow there with as, with the word as. You can do that in Ruby. I mean, there's ways basically to use method missing and all this stuff, and the parameters that are passed to it, and get the same exact result. But do you need to do that? Right? So there's trade-offs in terms of the complexity and the implementation, and this just applies as a universal rule. So in going towards natural language style in your DSL, be careful that you're not sacrificing the elegance of your code by creating this incredibly complex implementation of it just to get one little step further along the natural language.
So in other words, you have to balance the convenience for the DSL user with the complexity and the effort to implement
Correct.
DSL.
And this is probably something that is somewhat unique to this whole issue of creating internal DSLs, because you're relying on an existing syntax. So the question is, how much do I want to include? How much do I want to, break through that abstraction layer by including elements of the underlying programming language? Whereas in an external, you would have 100% control, so you're always making those decisions.
But still, you have to trade off the amount in general the power of the DSL and the amount of exceptions to standard behavior it can handle. You have to balance that with the amount of effort you put into building all the infrastructure. On that level, it's the same.
On that level, it's the same. I agree.
So the next one is sandboxing or context, right?
Yeah. So this is the way that, for the most part, when we're talking about using DSLs in a business context. It's typically in the sense of, let's write a script that describes some business rules or some business logic, which can be directly influenced, if not written, and maintained by the end user or by the domain expert. And then what we do is we take that and we execute it in different contexts. It's the same Ruby code. We don't have to transform it in any way, but just depending on what class, context you execute it in, it does different things. And the example, a good example is Capistrano is implemented in this way,
which is this deployment tool.
This deployment tool for Rails, which means you don't have to, for instance, like in the builder example, we prepended XML dot to everything. But if you do things this way by being fancy with your bindings and the block context that things get executed in, you can leave that off. So for instance, the one of the example deployment tasks that's included with all the Capistrano recipes is a transactional deployment. So task deploy do, transaction do, update code, disable web, symlink, migrate, end. It's a very readable, very, very little noise there.
And the do is actually the keyword that introduces a block.
Yeah, the do is a keyword that introduces a block. And there's different contexts there, and they're all linked together in a way that produces, some state which you will then execute it. As I started to mention before, you can keep bits and pieces of DSL scripts in the database. And this is something that I've found personally extraordinarily easy to abuse and have fun with, I would say, in Rails. Associating little bits of DSL-ish type script that modifies the behavior of, for instance, active record objects, and storing that in the database and loading it in at runtime.
And that's, of course, mainly a way of getting around some of the limitations by the deployment folks who say you can deploy only once a week and you want to do, faster changes.
Oh, you're lucky if they say once a week. Most of the times it's once a month, right? Or once a quarter.
So you can tweak stuff in and they think it's data.
That's one of the clever, that's one of the loopholes that you can use in certain organizations if you need to. And it can be quite effective. And actually, it can be safe as well, because that little snippet of executable code can even though it's in Ruby, you can put constraints around it to make sure that it is secure and it's not going to present a problem to you.
Yeah.
Rolling out what is in essence live production code.
Yeah.
It just happens to be stored in the database. So there's some funny issues around that.
Yeah.
But you would typically implement that by using this technique of context or sandboxing, as James refers to it.
Yeah.
And then the funny thing is that in creating those contexts, or I think we mentioned earlier, you would TDD those.
Yep.
And in TDDing them, you would go through and you basically start from the beginning of your script and make your script work.
Yep. TDDing, by the way, stands for using a test-driven process to and develop it.
Yeah, test-driven design.
Yeah.
So we've written our DSL script, which is basically the acceptance that represents when our script runs the way we intended to, then this feature this task is done.
Yeah.
That's our acceptance criteria. It's a high-level executable acceptance script in that sense.
Yeah.
And then in order to implement it, we have to start writing the context, the methods that will be invoked, so on and so forth. But we don't just write those blind, right? We begin writing unit tests for the context.
Of course, yeah.
In driving the implementation and using unit tests, now you create a meta model.
Yep.
Because now you end up with a object model that represents what you need to support your DSL script.
Yep.
And one of the reasons that I consider this agile is because you don't go above and beyond what you need to support in your script.
Yeah. Yeah.
You do only what you need to support the different instances of the script. That's why it's important to do a number of different scripts and basically consider different possibilities.
Yeah.
But here's where you don't trip yourself up as much in terms of refactoring in future. So considering changes that may happen to that language, if you've spent a considerable amount of time and money, in essence, going through a bunch of analysis, creating a big object model that's going to consider the possibilities up front, and now you've encoded the assumptions that you made in that meta model into your DSL, and it turns out that some of those assumptions were wrong, as they will be. Then that's going to have a bunch of impact on your existing code. But if you only do enough to support the existing DSL stuff that you've verified actually does express the intent of the domain expert, then chances are, and actually I can say this from experience with our projects, as things come up afterwards, there will be extensions. There will be growth of the language. There won't be changes. Yes.
Right. Yeah. That's my experience too.
And that mitigates the the impact of having to refactor DSLs
and evolve the schema.
Yes,
right.
Correct.
In terms of meta model. So So before we wrap up, I think it's useful to quickly look at some of the supporting features that you need in order to define DSLs. For example, I could imagine that if you want to define methods dynamically, Ruby has to provide some means of probably evaluating a string and making this actually source code or something like that.
Yeah, and like I said before, there is, for almost everything in Ruby, a couple different ways of doing it. So there are different ways of evaling at runtime. So it's almost macro functionality.
Yeah,
right?
exactly. Yeah.
Eval, just straight eval. There's performance considerations there. So these are not beginner Ruby topics, I would say. Get some Ruby experience under your belt. Definitely, get it. There's material available out there to see, what are the performance implications of using eval? What are the performance implications of using instance eval?
So what's instance eval and class eval and eval?
They have to do with what the actual execution context you want it to be in your Ruby code.
So instance eval modifies an object, class eval modifies a class?
Yes, essentially.
Okay.
We could talk another half hour about the subtleties of those.
Yeah, okay. We probably shouldn't.
And then you have things that are relatively simple to understand, like define method. To define a method, and
so you could define a method, pass in a block, or
yes, correct. And the block becomes the body of the method.
So basically, you're okay.
Alias method to do a little bit of AOP style things, where you can just have an existing method. For instance, you say, well, because of this configuration, for instance, let's say a class level method call. Well, I'm going to alias some existing method to wrap it. So I alias the original method to something old, and then I go ahead and
to create a new method that does something, then calls the aliased other method. And
correct. It's actually funny. I find it funny because when I was in Java for a long time, and like for instance, AOP was a big deal. A lot of people, still to this day argue back and forth about whether it's good, whether it's bad, when is it going to come around, when is it going to come away. But AOP concepts and things like this are already baked into Ruby, and they're like not a big deal.
Yeah, that's
in what we do from day to day.
We talked about that yesterday evening, and by the way, again, we're recording this at the JOE conference in Denmark, in Aarhus, in October 2006. We talked about this over the beer yesterday in the bar, how revolutionary and important and groundbreaking AOP really is, or is it just basically a workaround around the
limitations of Java,
of Java and similar languages, right?
Yeah. I think so. I think
I'm the moderator. I'm not. I'm saying. Not saying.
I think AOP is important.
Yeah.
But I think maybe they make too big a deal about it in those communities.
Yeah.
Whereas now that I've been part of the Ruby community for a while, I realized, wow, this is just another tool in the tool set that they've been using for years.
Yeah.
Yeah. If we want to talk about a little bit about just how you can take these business natural language. So I should say what business natural language is first. Business natural language, Jay Fields came up with a catchy thing. He said they're damp, not dry.
Yeah.
Descriptive and natural phrases.
Yeah.
So in business, and like we talked about variations in different contracts where they're mostly the same, but they have slight differences. And naive programmers, I shouldn't even say naive, say
beginner.
Typical enterprise type projects, you end up with a lot of copy paste programming, which many of us, look down our noses at and say, this is horrible. This violates OO principles in so many ways. It's not maintainable. There's problems with that. But if you take a pragmatic approach and you look at it, you say there's very valid reasons why sometimes enterprise developers go for that, and it's not just laziness. It's the fact that it's very easy, for instance, when I'm rolling on a new partner, to say, well, this one is just like partner X, except with these slight differences. So let me copy the configuration of partner X over and make the differences. And it saves me work, actually. So by creating DSLs to capture business rules in that sense, and if you create a framework around it, an application framework for people to easily be able to clone. And clone is a little bit less of a negative connotation than copy paste, in that context. But it's essentially saying the same thing. And then you put some workflow around it, and then you put some versioning, and you give tool support in the form of syntax checking, for instance, and then in the form of semantic checking. So I did ask the audience, kind of rhetorically, how crazy do you want to get? Because in one sense, this flouts the conventional wisdom of the vendors and lots of the way that people typically approach these types of problems. Most conventional wisdom, I would say, would look at a problem like the one that we tackled a few months ago using this approach and say, well, of course, buy an off-the-shelf business rules, or use Drools or something like that. But that's there's things that you get from that, but then there's a bunch of trade-offs that you make as well, right? And if we are trying to make all of our code and all of our implementation very elegant and very expressive and very verifiable in the ways that we've been discussing for the last hour, maybe you don't want to go that route.
Maybe you do it yourself.
And that's where having a powerful toolkit like Rails, for instance, in order to do it ourselves, and do it in 40 lines of code. I'm exaggerating, but the point is that it makes so many things so easy that actually lets you go off and be more creative in these directions. And still come in under time, under budget.
which comes back to the point that I think languages and language design and being able to extend languages to define relevant abstractions is really something that is maybe more important than using X number of frameworks and technologies. So it's probably underestimated.
I think there's a lot of room for growth. There's a lot of room for creativity and innovation in this field right now.
Okay, so I think let's wrap it up.
Yeah, thank you, Marcus.
Thank you for being on the show, and we'll put a couple of links to some of your blogs and slides and stuff into the show notes.
Yeah, thanks again.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.